Welcome to this video where we explore one of the most awe-inspiring and fearsome objects in our universe, black holes. For decades, these enigmatic gravitational monsters have fascinated astronomers, physicists, and everyone intrigued by cosmic mysteries. But have you ever wondered what would truly happen if you, theoretically, fell into one? How would an outside observer see you? How would you experience it yourself? And what lies beyond the event horizon, where our known physics starts to unravel? Let's dive into the depths of current scientific understanding. What exactly is a black hole? Singularity and event horizon. A black hole is a region of space-time where gravity is so intense that nothing, not even light, can escape its grasp. The name black hole originates from the fact that no photons, light particles, can exit once inside, making the region appear completely dark against the backdrop of space. Right at the very center of a black hole, according to classical theory, lies the singularity, a point, or something even more mysterious, where density and space-time curvature become nearly infinite. We still don't know if it's truly an infinite point or if some undiscovered physics emerges there. Around this singularity is the so-called event horizon, an imaginary boundary from which there is no return. Once any matter or light crosses that horizon, there's no escape. Intriguingly, the horizon itself is not a physical barrier, but rather a region in space-time defining the point of no return. Different types of black holes. Black holes come in several forms. Stellar black holes form from the collapse of massive stars. As supermassive black holes, with millions or billions of solar masses, reside at the centers of most galaxies, including our own Milky Way. There are also hypothetical primordial black holes, which may have formed shortly after the Big Bang. Despite differences in size and mass, the principle remains the same: an extremely curved region of space-time where gravitational effects dominate everything else, pushing the limits of our understanding of physics. How would you look to an outside observer? Now let's imagine you're on a one-way journey toward a black hole. First, let's consider it from the perspective of someone watching you from a safe distance. Say, from a spaceship orbiting well outside the black hole's lethal gravitational zone. Time dilation, freezing in time. General relativity tells us that time and space are intertwined, and gravity alters the flow of time. From the viewpoint of an external observer, as you approach the event horizon, you appear to slow down dramatically. The closer you get to the horizon, the more time seems to stand still from their perspective. In theory, you'd never be seen crossing the horizon. Instead, you'd seem frozen near it indefinitely, redshift and fading away. In addition to this slowdown, there's gravitational redshift. The light you emit loses energy while climbing out of the black hole's strong gravitational field. The external observer would see your image grow dimmer and shift to redder wavelengths over time, until you seem to vanish. In essence, from an external standpoint, it looks like you never quite make it inside, even though from your own perspective, which we'll explore next, you continue on your way. How would it feel to you? This is where the story gets more intense. What would you personally experience as you plummet into a black hole? Be prepared, the journey wouldn't be pleasant. Crossing the event horizon, a subtle transition. Contrary to what you might expect, the event horizon itself might not present an obvious barrier. According to classical relativity, you could pass through it without noticing a physical boundary. No sudden jolt or wall. In a supermassive black hole, the gravitational gradient at the horizon can be relatively mild, so you might not be torn apart immediately at that specific point. However, the environment around most black holes is anything but gentle. Fierce radiation, hot plasma in an accretion disk, and intense magnetic fields. But if we imagine a purely theoretical scenario free of external debris or intense radiation, you might cross the horizon without a visible demarcation. Spaghettification. When gravity stretches, regardless of whether you notice the horizon or not, spaghettification, the tidal stretching by extreme gravity, is likely to get you. As you fall feet first, for example, the gravitational pull on your feet can be enormously greater than on your head. This difference pulls you apart, stretching you into a long, thin shape, much like a spaghetti noodle. Very quickly, you'd be torn into atoms. For a smaller stellar black hole, this would happen well before you even cross the horizon. In a supermassive black hole, the tidal forces near the horizon might be weaker, and you might cross it intact, only to face unstoppable tidal forces further in. The passage of time from your perspective. From your point of view, your clock runs normally. You wouldn't perceive yourself slowing down. However, looking outward, if you could still see the outside universe, you might observe external clocks appearing to speed up, as relativistic effects reverse the situation for you. But your time in the black hole, from crossing the horizon to reaching the singularity, if classical theory applies, would be short. Suffering from intense gravitational gradients, you likely wouldn't have long to reflect on the surroundings. What happens beyond the event horizon? Heading toward the singularity. Once inside the event horizon, classical general relativity indicates there's no turning back. You're inevitably drawn toward the central singularity. Essentially, all your future timelines converge on that point. We can't precisely say what occurs within the singularity, since our current laws of physics break down there. This calls for a quantum theory of gravity, a field still under development. The information paradox. One of the biggest mysteries is the information paradox. Quantum mechanics asserts that information can't simply be destroyed. Yet black holes appear to swallow everything irretrievably. Stephen Hawking introduced the concept of Hawking radiation, suggesting that black holes evaporate over time. But what happens to the information that fell in? Some theories propose it's somehow encoded at or near the horizon. Others suggest alternate explanations. The debate is ongoing and forms a cutting-edge puzzle in theoretical physics. Wormholes and exotic ideas. Certain solutions to Einstein's equations hint at wormholes. Potential tunnels connecting one region of space-time to another. Could falling into a black hole transport you across a cosmic shortcut to a far corner of our universe? Or even another universe? Most physicists think any such structures would be highly unstable, if they exist at all. Still, it's fascinating to speculate that a black hole might not strictly mean the end, but perhaps a bizarre transformation beyond normal space and time. Conclusion. Sounds like sci-fi, but future discoveries might reshape our reality. So, what would really happen if you entered a black hole? From a classical vantage point, it's not a journey you'd survive. To an outside observer, your descent would slow and freeze near the horizon, while you, in your own frame, might notice no distinct horizon crossing, until the tidal forces tear you apart in a dramatic spaghettification. Past that horizon, theories differ, but almost all lead to annihilation by the singularity. And beyond it all looms the information paradox, a sign that our understanding is incomplete. Black holes push the limits of space, time, and physics, merging relativity with quantum mysteries we've yet to solve. As we refine gravitational physics, possibly through breakthroughs in quantum gravity research, we might discover more about these cosmic maelstroms, maybe even altering our concepts of matter, energy, and reality. It sounds like science fiction, but who knows? One day we may unlock deeper truths that revolutionize our views of the universe. For now, any voyage into a black hole remains a mind-bending thought experiment, and a fatal one in practice. Stay tuned. If you enjoyed this cosmic deep dive, don't forget to smash that like button, subscribe for more cutting-edge space and physics content, and share this video with friends who love extreme science and mind-boggling cosmic tales. The universe holds countless mysteries, and black holes are just one thrilling chapter. Thank you for watching. See you next time.